Hello, welcome to the webinar about automated oxygen, nitrogen and hydrogen analysis. In the following slides, I would like to introduce you the autoloader and of course ELTRA and Werder Scientific, and please enjoy the webinar. In the following, I would like to give you a short introduction about the webinar, about the speaker, and of course ELTRA, Werder Scientific, and the basis units which is used for automation, the elementary ONH-p2. Then I would like to introduce the autoloader for this unit and discuss all features and technical details. My name is André Klostermeier. I'm product manager at ELTRA since 2013. I studied chemistry in Germany in the city of Münster, and I have a PhD in analytical chemistry. And my job at ELTRA is making webinars, making marketing, and of course also technical things like make application notes, answering customer questions. So I have a broad mix of jobs, and so please enjoy the time here, and hopefully I can give you a valuable information. This webinar is done like this, that you can ask questions via the task menu, and you can just go to the topic questions and then just write something into the field, and then maybe I can answer it directly. Otherwise, when there are a lot of questions and maybe some questions are of general interest, then we can discuss these questions at the end of this webinar, and then I will switch my camera on again. But in the following, I will switch my camera off and use a headset for introducing all technical details, because then my voice is a little bit clearer, and for me it's a little bit more comfortable. So please enjoy. Hello. Let me first introduce ELTRA and Werder Scientific to give you an idea what is our job, what are we doing, and which analyzers do we have in our portfolio. ELTRA is a German company, and it's located in Hahn, which is a small town near Düsseldorf, and maybe you see it here on the card. And since 1981, ELTRA is focused on the production and development of combustion and inert gas fusion analyzers. We have analyzers for oxygen, nitrogen, and hydrogen, and of course for carbon and sulfur. Sometimes they have an induction furnace, and sometimes they have a resistance furnace, and they are usually compliant to all international standards which deals with combustion and inert gas fusion analysis. Besides these elemental analysis, we also have a thermogravimetric analyzer, which is able to determine the moisture, ash, and volatiles in typical samples like coal and coke. ELTRA is an important part of Werder Scientific, which does mean that we have in our group not only experiences in elemental analysis, but also in furnaces and ovens, sample preparation via cutting wheels and hardness testing, and also sample preparation via mills and jaw crushers, for example. And of course, we not only disintegrate samples, we also can measure the particle size, and this is, for example, something which is done by MRB. So maybe you don't know ELTRA, but maybe you know some other of our companies, and usually when you're working in a lab, you have something to do with one of our other brands. First, I would like to introduce you the elementary ONH-p2, which is the base which is used for automated sample analysis. For you, it's the chance to see how is manual analysis done. And the other thing is maybe you have not a good feeling if you are right here in this presentation. Then I will show you which kind of samples we are analyzing and which standards we are compliant with. So then you have a good feeling if you still can stay with us, or maybe this automated sample analysis is not the things you are needed. The elementary ONH-p2 is an inert gas fusion analyzer. This kind of chemical analysis is described, for example, in the ASTM E1019. In the picture, you will see the analyzer, which is configured as oxygen, nitrogen, and hydrogen analyzer. And on the right side, you see an extra option. It's an auto cleaner for the upper and lower electrode. Maybe you know ELTRA from former times, and the analyzers have been gray with, I would say, rudimental software. But what we have done in the past is develop a powerful software with some more options like support of quadratic and cubic calibrations. We can use drift samples. We have a powerful CRM library. And the thing which is important here and which is discussed in the following is we have solutions for automation. On the one hand, this does mean we have solutions for working with autoloaders, and we also have the solution to work with robots, which does mean that everything is done by external partners, and we have robots to operate with the analyzer. This is not part of this webinar. We will focus on the automated analysis via autoloader. The special features of this analyzer is, for example, a precise and good analysis of powders and granulates. We also have a very fast cycle time and analysis time. For example, copper, oxygen and copper can be done in a cycle time below 3 minutes. And something which also is used widely for this kind of analyzers are options like carrier gas purification furnace or things like the auto cleaner. When you are not familiar with oxygen, nitrogen, and hydrogen analysis in metal samples, I would like to give you a short introduction how it is done in a manual way. Usually you start your analysis procedure with logging in the sample in the software. You type in the name and then you weigh the sample and fill in the weight or take the weight over by the software. Then you apply the sample in the sample port, and this does mean that in the sample port the sample is freed from atmospheric gases like oxygen and nitrogen. After you apply the sample, you can put in a new graphite crucible to the lower electrode, and then you start the analysis in the software. And then everything is done automatically, which does mean you close the furnace and heat out the graphite crucible to free it from atmospheric gases, and the temperatures which can be reached are up to 3000 degrees Celsius. And at the same time, you flush the sample with inert gas like helium to remove atmospheric gases. And when the sample falls into the hot crucible after degassing, you have chemical reactions like forming of carbon monoxide and subsequently carbon dioxide. And other gases like hydrogen and nitrogen are released from the sample as pure gases. Then you have a detection of these elements. Hydrogen and nitrogen are measured in a TCD cell, and oxygen is measured as CO2 in infrared cells. And after you degas the sample and released all the gases, you will find some measuring curves in the software, and these measuring curves are integrated and gives you a result of the present gas concentration. The reasons for automated analysis could be very different. On the one hand, you will save money for staff. This does mean that you can plan your staff for other jobs because they do not have to sit in front of the analyzer. Because when you have one sample or two samples, it doesn't matter because the cycle time is done within 3 or maybe in maximum 5 minutes, and it's not boring to analyze 1, 2, or maybe 3 samples. But when you are in a company which has to, I would say, analyze 20 or 30 samples a day, then it is a little bit time consuming to sit in front of the analyzer and wait just for the next analysis. And this does mean, for example, that you have a better chance to plan your stuff and can reduce cost for staff when you have an autoloader. And automated analysis, and this is something I would like to explain to you, could mean two different things. On the one hand, our analyzers are integrated in an automation. This does mean everything is done by robots. Then you need a different partner. They have to integrate it in a special area, these kind of machines, and they have to work with robots and external sample preparation and all these kind of things. This is something we can do also because our software does support the communication with other external softwares, but this is not part of this presentation. This presentation just takes care about semi-automated analysis with an integrated autoloader. In the beginning, I would like to describe you the general challenge of developing an autoloader or using an autoloader for an oxygen, nitrogen, and hydrogen analyzer. For this kind of inert gas fusion analyzer, it's a little bit more complicated to work with an automated analysis because we have to provide different things and we have to find solutions for, I would say, technical challenges. On the one hand, we have to provide a sample carousel or a solution for introducing the sample to the sample chamber because every sample which has to be analyzed has to be freed from atmospheric gases like oxygen and nitrogen. On the other hand, the graphite crucible which melts the sample is located in another part of the furnace. And this does mean that we have to find a solution for crucible management. This does mean storage, and this does mean transportation, and this does mean also putting the used crucible into waste. And all these things are for oxygen and nitrogen and hydrogen analysis a little bit more complicated and a little bit tricky. But ELTRA is proud that we found a good and reliable solution for this kind of challenge. And in the following, I would like to introduce you the autoloader. For a good understanding of the autoloader, I would like to show you in first run a video. How does the autoloader works, which component is located where, and how do they work together. And this is shown in the video, and then it's a little bit more easier to discuss technical details because you know where everything is located and how the workflow is in general. Don't wonder the video was spoken by a professional speaker, so you will listen to another voice in the next video. Thanks.
Today we would like to introduce our new autoloader for our ELTRA ONH-p analyzer. The sample carousel has 32 positions. The carousel can be easily removed from the analyzer for convenient filling. The carousel is coded. Up to 3 carousels can be assigned to one analyzer. When the carousel is set up, the analyzer recognizes it and automatically selects the correct sample list. The graphite crucibles can simply be poured into the receiving hopper of the autoloader. They do not have to be aligned in a time-consuming manner. The autoloader supports you in your efficient laboratory operation. Up to 32 analyses can be performed fully automatically and autonomously. The gripper arm removes the crucible after analysis and disposes of it in an integrated waste container. In parallel, the next crucible is automatically aligned for analysis. Necessary accelerators are intelligently fed via the sample carousel. The crucible is precisely placed on the crucible tip with the gripper and the furnace is closed. The sample, or the accelerator, and the sample are metered in via the sample carousel. At the end of the analysis, the furnace is opened again and the next sample on the list is processed. Depending on the sample matrix, the auto cleaner can be used during autoloader operation to clean the furnace chamber and the crucible tip to ensure long-lasting reproducibility of results. Contact us or one of our distributors to learn more about our autoloader and its benefits.
I would like to summarize what we have seen in the video. On the one hand, which is marked here with number 1, we have the carousel where you can apply your sample and maybe sample and additional flux. What does this mean, management of flux? I will discuss in the following and in the next slides. Then we have an auto cleaner, which is part of the delivery content of the autoloader, because we highly recommend cleaning after 2, 3, or 5 samples, and this increases the repeatability of all samples you measure. Then we have the crucible magazine, where you just put in your crucibles. It's here located in position number 3. Position number 4 here shows the gripper, which took a new and an old crucible and replaced it on the lower electrode. The thing which was not shown in so much extent is the waste bin of this autoloader. It's here marked with number 5. You can just press it there, and then you can put all the used crucibles into the waste. One other thing which is also not shown in the video is a chiller, which is recommended for most of the applications, and this is something I will explain on the next slide. One topic which was not shown in the video was the utilization of cooling. ELTRA recommends to use a chiller because this chiller can provide a constant temperature for all applications and all over the analysis time. And this does mean a constant temperature in the furnace, and this does mean that we can assure that every application works, because the chiller can guarantee that special temperature at the furnace is always constant. This reduces also cooling time and post-waiting time. And depending on your sample and depending on your application and depending on your throughput, the chiller is highly recommended to assure a reliable work over a long time. When you are listening to this webinar and see maybe how it works, how automated analysis works in general, you maybe ask yourself, is this suitable for my samples, and can I process my samples with the autoloader? And this is something I will discuss on the next slide, because automated ONH analysis could mean something different in comparison to manual analysis. The most common application for automated ONH analysis is the analysis of steel, nickel, copper in solid pieces. This does mean that you have only one piece of sample, usually up to 1 gram, and this is a sample you just put in the carousel and apply a standard application, and that's it. When you have powdered or drilled samples, the application is a little bit different. Powdered samples you have to apply in a capsule. This is required for manual analysis, and this is also required for automated analysis. Granuled or drilled samples are a difference in manual and automated analysis. When you have the ONH-p without an autoloader, it's very easy because you can apply up to 2 grams to the upper furnace, and then the sample is flashed and analyzed in the graphite crucible. But when you are performing automated analysis, you have to take care about the rotation of the carousel. And this does mean, that you have to fill in the sample in a capsule, because this capsule can be processed safely in the carousel, whereas the pure application of granules in the carousel does not mean that every sample could be transported reliable. When you are leaving the typical applications like nickel, copper, steel, or whatever, and are going to refractories like titanium, you have to consider the standard. And this does mean you are limited to 0.1 gram. And this solid sample of 0.1 gram is usually placed in a basket. This is no problem because the holes in the analyzer carousel are big enough, so you always can perform a titanium application. When you have powdered samples, you also have only consider the standard, which does mean you have to fill in up to 100 milligram of powder, put this powdered sample in a capsule. This capsule have to be placed again in the basket, and the basket is something you can apply directly to the sample carousel. So this is also no problem with the Elementric ONH-p2 with autoloader. A special challenge is the automated analysis of hydrogen in titanium, because for this kind of sample you have to use tin pellets as flux material. And as you have seen in the video, all crucibles are aligned automatically. And this is maybe not a good procedure to apply a flux like tin pellets. And how this is done and how you can measure these samples is shown in the following. But please consider that this kind of analysis is limited to a sample weight of 0.25 gram. This is not due to the analyzer, but this is due to the regulations of the standard. On this slide, I would like to stress again the difference between automated and manual analysis. Manual analysis is always a little bit easier because you can make sure that every sample is directly transported to the sample port. And when you have a carousel, you maybe have to be more on the safe side. And this does especially mean for this granule samples, that you have to fill in these granule samples in capsules. And when you have to use capsules, you maybe have to think about maximum sample weight, and this is something you have to consider. When you are unsure if you can process your sample with an autoloader, please send us some samples and then we can perform some tests. And the analysis of hydrogen in titanium, which does mean application of extra flux, is explained on the next slides. When you are not familiar with ONH applications in general, and maybe you know only your sample, then here we have some basic picture which illustrates how it's done in general. When you have a powdered sample, you just fill in the sample in a capsule, or when you have a granule sample, you also fill the sample just into a capsule, and this is something you can directly apply to the carousel. Titanium samples are also easy to handle, because you just weigh your sample and put this in a basket, and this basket is directly applied to the sample carousel. And here you see the typical filling of the carousel for a standard application, which does mean position 1 contains sample 1, position number 2 contains position number 2, and so on. Of course, it's possible when the carousel is put on the analyzer, when, for example, 10 or 15 samples are measured, it's always possible to introduce new samples, because you just can fill in position number 1 again, and or fill in position number 2 again, as long as the sample is already analyzed. For hydrogen in titanium analysis, the filling is a little bit different, because the standard forces you to use tin pellets as flux. And when you remember the video and how the crucibles are aligned in an automatic manner, it is not possible to fill in the tin pellets previously. So the Elementric ONH-p2 autoloader has to find a solution for this kind of application. And this is very easy, because you fill in position number 1 the 2 tin pellets, and in position number 2 the sample. And what does happen in the analyzer? Well, it's a little bit different in comparison to a standard analysis. When you want to analyze hydrogen in titanium, you have in position number 1 an open furnace. This does mean the flux is passing the sample port and falls directly into the crucible. Then the sample port closes to the lower furnace, and the carousel rotates again, and the sample falls into the sample port, the sample chamber. So then you have a solution like manual analysis. You have the tin pellets in the lower crucible and the sample in the sample port. And then the typical analysis procedure starts, and you have a heating of the crucible to remove atmospheric gases from the crucible and from the flux. And you also have a flushing of the sample for titanium. So this does mean for this kind of application, you just have to use different positions for flux and sample. In the beginning, I explained to you that the automated analysis for inert gas fusion analyzer could be a little bit tricky because you have to take care of the samples and you also have to take care of the crucibles. So every, I would say, company on the market which offers automated oxygen, nitrogen, and hydrogen analysis has a solution for this kind of challenge. But what is different at ELTRA automated analysis and what is the thing we are doing smarter and even better is shown on the next slide. One important statement for the Elementric ONH-p autoloader is that we can support any application. So it doesn't matter if you have copper, steel, titanium, or whatever, we can process every kind of sample. And as I mentioned before, it even doesn't matter if you have a powdered sample, granular sample, or a solid sample. Everything can be processed with our analyzers. One nice feature is the 32-position carousel. In comparison to other manufacturers with have a 20-position carousel, we can process 12 samples more. This maybe does not sound too much, but when you consider a typical analysis or maybe cycle time of 4 or 5 minutes, that does mean that we have roughly 1 hour more where the analyzers can operate without any stuff. One other solutions which show that we have a very, I would say, user-friendly analyzer is the space. When you have a look at the standard autoloader and a standard ONH-p2 auto analyzer in comparison to an ONH-p2 analyzer with autoloader, you see that the required space for this autoloader is negligible. And this does mean that we don't need so much space, and maybe in your lab you don't have so much left space for additional equipment, and we have a very smart and compact solution to provide an automated analysis. One other thing is the automated alignment and replacing of crucibles. We just have to fill our magazine and that's it. When you have a look at the other solutions of other manufacturers, which does always mean that you have to align the crucibles per hand, and this is sometimes time consuming. And this does mean the time maybe you are winning when you use an autoloader is maybe a little bit shorter when you have to do some work in a manual way. And this is the reason why the customers we have already at the moment like our autoloader, because it's very user friendly and it's very, very fast. When you would like to see the video again, or maybe you would like to get more information about oxygen, nitrogen, and hydrogen analysis in general, or about the autoloader, you can go in first run maybe to our homepage, and it's available in different languages. You can see the video and check specifications and download a brochure, and then you really get a good feeling about this kind of analysis and of course how the autoloader works in general. When you have questions, you can just contact ELTRA in Hahn, of course, but you can find on our homepage also local contacts where you can contact ELTRA in, I would say, your local language. We can arrange a demonstration, of course. Maybe not every lab of our distributors has an autoloader in their lab, but something which is always possible, making a demonstration via internet. And then when we have a demonstration via internet, you also see typical workflow and you can ask questions. So this is very, very comfortable. And this is something we used especially during the Corona crisis when visits have been not possible. So an online demonstration is a solution for everybody of you. So please, when you would like to have a demonstration, please ask us. And when you have other application questions or maybe other technical questions, you can also ask your local contact persons or maybe go to the internet and write an email to ELTRA in Hahn directly. You are highly welcome. Yes, and that's it. Thanks for your time. And I will now take care about your questions. Maybe I already answered it in the chat, but when there are some questions left, or maybe some questions raise up which are in interest of for all of you, I will discuss them with you in the following. Yes, and the thing which typical questions which came up during these webinars are, on the one hand, the measurement, or not the measurement, but the management of flux material. Because on the one hand, you have flux material which really belongs to the sample. This does mean when you are analyzing titanium, you have to put the sample into this nickel basket, and then this nickel basket falls together with the sample to the crucible. And this does mean you only block one position, because it's like manual analysis. The basket and the sample belong together, and they can be handled as one sample. A problem came up, for example, when you would like to perform measurements with samples which need flux material in the graphite crucible. And in this case, and this is especially for hydrogen analysis in titanium, you have to usually apply this tin flux material in the crucible, and this crucible is outgassed. And this is the same procedure here. When you apply, when you lock in a sample as measurement with flux, this does mean you fill in position number 1 the flux material, and this falls directly into the crucible, and then the crucible is heated up with the flux and removes everything of blank value. And then after flushing the sample, the sample falls into the hot crucible with the flux material. And this is something you can do for your measurement. It's maybe also possible. We have at the moment in Germany, we have a customer who is analyzing a special alloy with this with our autoloader, and he's thinking of improving the precision by adding a mixture of a crucible with some graphite, for example. And this is something you can also do. You have the possibility to apply a flux material whichever is wanted. You can do it with your sample, then you need one position, or you can define it as flux which has to be outgassed previously, and then you need 2 positions. So this system in sum is totally flexible. The other thing colleagues asked is about the tip for the crucible, for the graphite crucible. It's a tradition, more or less, to make it from graphite in the elementary ONH-p2, and we have used it for many, many years. On the one hand, it's worn a little bit more. It has to be replaced more often in comparison to a metal tip for the crucible, but it has lower costs. We have, I would say, at the moment, customers who are running this autoloader for 30,000 samples a year. And at the moment, they are not unhappy with this graphite crucibles, because when something is blocked and when something is strange, they only have to replace a graphite crucible, and the, I would say, frequency of replacing for them at the moment, no trouble. Nevertheless, there's the request for such metal tip, which lasts a little bit longer and has to be replaced less often. At the moment, we are testing it, and then we can give you a feedback. But this is something which can be developed in the next weeks and months, because it's just a tool which can be replaced very easily. Yes, and these are the common questions for this kind of autoloader. As long no other questions raise up, I will stay online for 2 or 3 minutes when new questions came up. Otherwise, I would say thank you for your time, and I can give you the feedback that you have been the webinar with the most participants, and maybe you will start working today, or maybe you will stop working today. I don't know. So please have a good day, have a good time, and yes, enjoy Christmas time, and I wish you all a good new year. And that's it. Thank you for your attention.